Welcome to my YouTube channel Math with Poonam. I am here to make math easy and fun for you. If you are struggling with algebra or calculus or just looking to sharpen your problem solving skills, this channel is all about to break complex concepts into more easy and understandable steps. If you want to feel more confident with math, then make sure to hit the subscribe button and join the community. So let's get started. So today's topic is all about set theory. So before knowing about set theory, we have to know some notations which we are going to use later. Equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, not less than, not greater than, belongs to, does not belong to, or and, for all values of x such that. Actually here we are using the notation these for such that. We can also use these for such that, okay. Implies that, subset, proper subset or is contained in, is not contained in, contains, does not contain, negation or difference, complement of set. We can denote it by a dash or a bar also, okay. Union and intersection. Okay. So please pause the video and take a screenshot of the notations. So there are more notations in set theory which we will know. First, capital U or S denotes universal set. Capital Z, just see carefully the notation which denotes the set of integers. If we add plus on the top of the notation, then this denotes the set of positive integers. This is set of negative integers. This is set of natural numbers. Just carefully see the notations, okay? This is set of rational numbers. This is set of positive rational numbers. This is set of negative rational numbers, okay? Next, we have the set of real numbers. Capital R, you see the notation here, double line, okay? Which denotes set of real number. Set of real numbers. Next, set of irrational numbers. That is set of all real numbers minus set of all rational numbers. This denotes the set of irrational numbers. So, next, definition of set. Definition of set consists three components. One is well defined. Any two elements are different from each other and elements are independent of order. What is well defined means? So, well defined means one or more than one certain rules by which it is determined and an element can be a part of that set or not. For example, if you are considering the set of all colleges in the state Maharashtra, then this is a set. Why? Because there we are including only the colleges from the state Maharashtra, not from West Bengal or Karnataka. But if you are considering the set of all tall boys, then this is not a set. Why? Because there is no proper definition for a tall boys. To me, it is 5.5 feet. To you, it can be 7 feet, 6 feet, 5.9 feet. Okay. So there is no proper definition in this set. So this is not a set actually. Okay. This is not well defined set. And any two elements are different from each other. That means this is a set. Because there is two elements in this set, 1 and 2, and they are not equal to each other. But actually this is not a set because these two elements are equal to each other. Next, elements are independent of order. That means this is a set obviously and this can be a set also. That means the elements are independent of order. We can write 2 at first then 1. We can write 1 then 2. It doesn't matter, okay? Elements are independent of order. Now, each object which belongs to a set is called member or element of that set. And we denote the set by capital letter. And we denote the member of the set by small letters, okay? Now, if A be a set, if capital A be a set, then an element A belongs to this set A is denoted by A belongs to A. And we will pronounce it like that, an element A belongs to the set A. And if an element does not belong to this set, then we will write it like that, A does not belong to that set. The set. Okay, that's it. Next, presentation of sets. Different presentation of sets. We can define or we can present a set by these two methods. One is tabular method, one is property method. So what is tabular method? Tabular method is when we are actually aware of the elements of a set, then we can represent the set by this tabular method. Let's consider the set of all vowels. Okay, A, E, I, O, U. Here I am representing this set by tabular method. This is the tabular method. When I am just using these curly brackets and the elements are separated by commas. Next, property method. When we are not aware of the elements of the set, or we don't want to represent the set by this tabular method, okay, then we will represent the set by the rule which the elements of the set are following. Let A be a set and small a be an element of that set, and if every element, A is an arbitrary element of that set A, okay? If every element of A following a particular rule PA, then we can represent the set using a property method like this. A is equal to A such that A belongs to PA or not belongs to actually, such that PA, actually P represents this or P maintains or P follows this property or this rule actually, okay? We can denote it like that. For example, if we are taking the set of all integers between 2 and 10, by using this property method, we can represent it like that. If we name the set like B, then X is an arbitrary element of that set B, X such that 2 less than X less than 10. 2X is not equal to 2 and 10 here I am taking, okay? So this is the representation of set by using property method. But here we can also represent it like tabular method also. Like it should be 3, 4, 5, 6, 7, 8 and 9. We can. Okay. We can represent a set by using both tabular method and property method. But sometimes it is more convenient to use property method than this tabular method. Next, a few definitions of sets. Finite and infinite sets. If we can count every element of a set, then this set is called finite sets. And if we cannot count elements of that set, then it is called infinite sets. For example, A is equal to 1, 2. We can count the elements of that set. But if we take the set of all integers or the set of all real numbers or the set of all rational numbers, irrational numbers, then this is infinite sets. We cannot count the elements of that set. Next, singleton set. Singleton set is that set which contains exactly one element. Like this is a singleton set. If we consider the set of all integers between 2 and 4, set of all positive integers between 1 and 4, like x such that x less or equals to 4, less than 4 and greater than 2, and x belongs to the set of all positive integers. We will pronounce it like that. Set of all positive integers between 2 and 4. Set of all positive integers between 2 and 4. Only a element there, that is 3. So this is a example of a singleton set. Null or void or empty set. A set which contains no element, we will denote it by 5. Subset. If A, B be two element such that every element of B is an element of a set A, then B is a subset of A. B is a subset of A. Every element of B is an element of a set A, then B is a subset of A. This is subset. And A is said to be the superset of B. If A, B be two elements such that every element of A is an element of that set B, then A is a subset of B. Next, equal set. A, B, B2 set are said to be equal set if B is a subset of A and A is a subset of B. If these two criteria are satisfied, then we can say A and B are two equal sets. Next, proper subset. I have already told about the superset here. So I am telling here only proper subset. Proper subset is let A be B2 set such that there is at least one element in the set A which does not belong to that set B. Then B is a proper subset of A. Okay. So you can derive an example for this proper subset. Write it in comment. I will check in the next session. Next, universal set. Universal set is the biggest set. Like if we consider the set of all integers, set of all natural numbers, set of all rational numbers, then obviously the set of all real numbers is the universal set of those sets. Power set. Okay. As if a set if every element of a set is a subset of a specific set, then this set is said to be the power set of that set. For example, if I have set like A, B, C, A is equal to A, B, C. What kind of method is this? This is tabular method. I am representing this set by tabular method. Na? So, what is the power set? We will denote the power set by these, okay? Don't get confused between PA and P capital A. PA is the rule. The elements of a set are following, okay? But P of capital A here is denoting the power set. This is not a probability, okay? Here only. Okay, so P of A, that is the power set of A, is equal to every subset of that element. What are the subset? Singleton sets here, and also the combination of two elements here, and also phi also, because we will prove later that phi is a subset of every set and every set is a subset of itself. Okay, so phi also and A means A, B, C. So this is the power set of that set. So these are the definitions. Next, an important conclusion of set theory. Before that, we have to know about closed interval and open interval. So our set X is called closed interval if every element of the set X such that A lesser equal to X lesser equal to B and AB belongs to the set of all real numbers. And we will denote this closed interval like X belongs to closed AB. What is open interval? A set Y is called open interval if every element of that set Y are such that C lesser equals to Y lesser equals to D and also CD belongs to the set of all real numbers. We will denote it like that. Y belongs to open CD. Sorry, here we are not using this equal sign. Okay, in open interval here we are not using the equal sign. For closed interval we are using this equal sign. Okay, less than equal, less than equal. For open interval we are only using less than sign. Next, null set is a subset of every set. Let us consider a set A which is an arbitrary set. Okay, and phi is our null set. Sorry, phi is our null set. Now let's assume phi is not a subset of A. Then there is an element in the set phi which does not belong to that set A. This is contradicting our fact because phi is null set. It doesn't have any elements. So null set is a subset of every set. Every set is a subset of its own. Definitely, every set is a subset of its own. You have to think it. Okay, I will discuss it in the next session. Next, if A subset of B and B subset of C, then A subset of C. Definitely, A subset of B. What does it mean? It means X belongs to A implies X belongs to B, where X is an arbitrarily chosen element from the set A. Okay. If X belongs to A, this implies X belongs to B. A subset of B means. What does B subset element from the set B, then this implies X belongs to this set C. Okay. From these two facts, we can derive a conclusion that X belongs to A implies X belongs to C, because if A, B and C, this is A, this is B and this is C are two elements. X is an element of that set which belongs to this set. Okay, and this set already it is given that B subset of C. Therefore, this X belongs to this set C. Then definitely A is a subset of this set C. So here A is a subset of this set C. Next, A subset of B and B subset of A. Then A is equal to B. So next we have to prove if A subset of B and B subset of A, then A is equal to B, and converse is also true. Okay, so first we have to prove this part, then we will prove the converse part also. A subset of B means if X is an arbitrarily chosen element from the set A, then X belongs to A implies X belongs to B, because A is subset of B. We all know that. B subset of A, what does it mean? If Y is an arbitrarily chosen element from the set B, then Y belongs to B implies Y belongs to A. Now, X is an arbitrarily chosen element and X belongs to A implies X belongs to B. This means every element of A is an element of B. Okay. Here Y is an arbitrarily chosen element from the set B, and Y belongs to B implies Y belongs to A. So this implies every element of B is an element of A. Here X and Y are arbitrarily chosen element. Okay. So here every element of A is an element of B and every element of B is an element of A. So therefore A and B are two equal sets. Okay. Next, for the converse part, it is given that A is equal to B. It is given. We have to prove that A subset of B and B subset of A. I have already told the definition of the equal sets. If A and B be two equal sets, then by using notation we can say that it implies actually X belongs to A implies X belongs to B, where X is an arbitrarily chosen element from the set A, and Y belongs to B implies Y belongs to A. If A and B are two equal sets, then these two sets are follows these two property. Okay. So what does it mean? It means A subset of B and it means B subset of A. So therefore, if A and B are two equal sets, then A subset of B and B subset of A. So that's all for today. If you enjoyed this video, then please don't forget to hit the like button and share this video with your friends, and please subscribe my YouTube channel for more updates. Thanks for watching. I will see you in the next one.